Welcome to another segment of my mathematics videos. So this time we are looking at linear programming. So I'm making an introduction to what we are calling as being linear programming. So linear programming, is very important in mathematics because it can help you to establish the minimum or maximum profit, from selling certain items. So therefore we can use linear programming to do that. Now, of course, under linear programming, we use what we are calling as being inequality symbol. So the word itself, inequality, means not equal. Why? Because there is no equal sign when we are using inequality symbol. In fact, if you look at what we are calling as being the prefix in the word itself, the prefix in, simply means not. And if you look at, the root word itself, which we're using, the root word itself, equality, it simply means equal. So that's what we mean, not equal to. So that is why inequality. So for inequality, we use inequality symbols such as, greater than, or equal to, or less than or equal to, or just greater than or less than. So those are inequality symbols that we are going to use. So now when we are dealing with linear programming, these inequality symbols have got meanings and there are certain words that are used. So I just want to give you an idea of what words are used so that you become familiar as you use that. Remember, this inequality symbol there simply means less than or equal to. So that is less than or equal to. So less than or equal to that. So that's what it means. Now, what words are going to be used when it comes to when you are using when they want you to use less than or equal to? Well, you are going to find words like at most. So we'll be using words like at most. Those are words that we use. Sometimes we are going to use is not more than. So it's not more than. So they may use words like it's not more than, or we can say they can use words like is not, greater, is not greater than. So those are words that we can use, or we can use words like does not exceed. Well, when they use such words, it simply means that the inequality symbol that you need to use is actually less than or equal to. So that is what we mean. For example, if you have got x is maybe less than or equal to 5, or you can maybe say 2x, you can simply say that 2x is actually less than or equal to 15. That's what we mean. So less than or equal to. So those are some of the terminologies they can use. This symbol that you see here is what we simply call as being, less than. But what words are going to be associated with less than that you're going to find? Well, words that we use include things like, is less than. So we are going to be using words like is less than. We can use words like, is fewer than. We can use words like, is under. We can use words like is below. When you find such expression in a statement, mathematical statement, then you can use, less than symbol. For example, if I have got maybe x is less than 5, or maybe 2x is actually less than 15, you can see that here we are not including, the equal to sign. Another symbol that we can use is what we are simply calling as being this symbol here. When you see it, means greater than or equal to. So that's the symbol, or equal to. So what terminologies are associated with greater than or equal to? Well, you're going to find terminologies like at least. So they are going to be using words like at least. They can use words is not less than. Yeah, it's not less than, or we can say is no less than, there's no problem. Is not under. So those are some of the terminologies that they can use. Or you can find this expression here can also be indicated is no less than. So those are some of the terminologies that are used when they want you to use greater than or equal to. For example, if x is greater than or equal to 5, or maybe 2x is greater than or equal to maybe 15, it is possible you can use that. The last but not the least is actually the symbol that you're able to see there, which means greater than. So what terminology is associated with that? Well, when we use the word greater than, we can simply say, we can use words like is maybe greater than. You can find words like is more than. You'll be able to find such expression. You'll be able to find the word exceeds. So I've only used the word exceed. I've only used the word exceed. Then is over, and so on and so forth. But these are just ideas that will introduce you to linear programming. For example, if I have maybe my x is simply greater than 5, or my 2x is simply greater than 15. So these are some of the inequality symbols and the words that we use when we are dealing with linear programming. But other concept that you need to remember is that under linear programming, we are going to be using what we simply call as being solid lines. So we can use what we are calling as being solid lines. So when can we use a solid line? Well, you can use a solid line when you find inequalities, when you are using either greater than or equal to, or less than or equal to. Then you can actually use what we are calling as being a solid line. So this is the first instance where you use a solid line. Again, you may find what we are calling as being dotted lines. So we can use dotted lines in case we are using inequality symbols such as greater than or just less than. Then it simply means that the line is going to be dotted. Now, a quick fact again that you need to remember: if you have let me say you have what we are calling as being you have your x or y plane, and you find that you have got a line that is actually parallel to what we are calling as being, the y-axis. Well, if you have this line, going this side of the line, we consider it to be greater. So to be greater than. Now remember, it depends with the line. If the line that you are using is actually a solid line, then it will be greater than or equal to. Going this side is considered to be less than. If this is a solid line, then it is going to be less than or equal to. Of course, you can notice the numbers going this side are increasing on the number line, and that's why we are saying this side is greater than, and going this side is actually less than. So you need to remember that. Now suppose I had again a line. This is the x or y plane. This is the x or y plane, but this time let's say that I have a dotted line. It doesn't matter where the line is, whether in the positive or in the negative, the concept still applies. If you are going this side, of course it is still greater than, because the numbers are increasing. But what we are going to be doing in this case is that because this is a dotted line, we're just going to say greater than without adding the equal to. If you are going this side again, it is just going to be less than without the equal to. So please, these are quick, important concepts that I want you to appreciate, because later on, as we look at typical questions, I'm going to address, how you can go about that. Let's put up something else. Again, I'll say that's the B part now. Suppose, and now, let me say the B part. Let me say that, suppose you have a line that is, actually parallel to the x-axis. On the other hand, we can also have a line that is, parallel to the x-axis, but let me say it is a dotted line. Well, going this side, if I start with the first one, going this side of the line, going upward, as we go upward, we can use greater than. So it's greater actually, but because this is a solid line, it simply means the inequality symbol will be greater than or equal to that. You can use that side. But if you are going down below this line, the numbers will start decreasing, so it is going to be less than. Yeah, because this is a solid line we are dealing with, then it simply means it will be less than or equal to. Now, what about if I have another line parallel to the x-axis? Suppose it's a dotted line. Like I said, it doesn't matter whether this line is in the positives or in the negatives, the concept still applies. So if I'm going up, like I said, it's still greater than, because the numbers are increasing. But of course, because this is a dotted line, we are just going to say just greater than. What about if I wanted the region below this dotted line? Well, of course, the region below is actually less than. And because this is a dotted line, we are just going to say less than. So we are not going to put the equal sign. It is just less than. Those are important concepts that you need to remember. All right, let's put up some other concepts that will help you to quickly, both in your paper 1 and in your paper 2. Let me call it as pin C. If I have a line, in this case, if I have a line, and that is my x or y plane that I have, and the slope of this line, the gradient is positive. Let's say the line is sloping like that. Again, it doesn't matter where the line is sloping like that. Remember that if you have a line like this, going up of this line, going upward, if the slope is positive, going up the line is actually considered to be greater than. So what inequality sign do we use there? We use actually greater than or equal to, because that is a solid line. Then going below this line, you can simply use, in this case, less than. It's less. So because it's a solid line, you can use less than or equal to. That's the concept that you need to have. At the same time, if I still have a line, the x or y plane, let me say that maybe my line is still passing down here, but this time the line is a dotted line. Still going up there is simply greater than. So you are still going to use your inequality sign greater than. Going below this line is again going to be less than, because this is a dotted line, no equal to. Remember, it doesn't matter whether the line is below or up. The concept is that it's supposed to have a positive gradient. Remember, when a line is sloping like that, what we told you, the gradient is always positive. So that's what we mean in that case. Well, let's put up our last concept. Let's put up our last concept there. I'll call it D, that you need to remember. So for D again, if we do have again our x or y plane there, and this time our slope is actually negative, going this side of the line, if this is the line, going up the line is considered to be greater, is greater than, and because that's a solid line, it will be greater than or equal to. If you were to go below, if the region you wanted was below this line, well, that is considered to be less than. So we are going to use, less than or equal to, because that is a solid line. Well, suppose again I had a dotted line. Suppose I had a dotted line in this case. Suppose I had a dotted line. Well, the same concept still applies. Going up will still be considered greater than. But because this is a dotted line, remember, it is just going to be greater than. Below this line, if you were to go the region below this line, if you are to go below this line, it is still going to be just less than, because that is a dotted line. So these are concepts that you need to remember under linear programming. And I can assure you, these concepts that I've talked about together with the inequality symbols and their meaning, this is what you need to remember in order for you to understand linear programming. I'm going to show you how you can use this concept to come up with inequalities and hence plot them on a graph. Please watch out for my next video. Thank you so much for watching.